Hello. Hi, so my name is Cameron Beccario again. Nice to meet you. I'm presenting now not as an Indeed employee, only in English. Sorry. This is a project that I worked on before I joined Indeed. And my Twitter is cambeck, if you want to follow me. So, what is Earth? This is the name of my project. Earth is a wind map project that I created to learn how to use web technologies. So tonight I'm going to talk about 4 main topics: motivations, construction, reactions, lessons. But first, a quick intro. I am originally from Cedar Rapids, Iowa, in the middle of the United States. Nothing is there, just corn and pigs. And I graduated with a computer engineering degree from Iowa State University. And after that, I moved to Seattle to work for Microsoft for 5 years. Got a little tired of that, decided to move to Japan and study the language, even though I'm using English right now. And took a job, various companies around, and eventually ended up at Indeed as an engineer, software engineer. So let's talk motivations. Back in the summer of 2013, I had no job. I collected stamps. Stamps. Engineer. Not a good sign. I needed a new project, something to learn new skills. And I knew I wanted to do some HTML5, some JavaScript, didn't know JavaScript, learn Node, data visualization, but what to build? Well, I saw a nice inspiration. This was a site that I found in 2012, hint.fm/wind. This is built by a couple of researchers from they're at Google now. And when I saw this, I thought, this is really cool. A browser can do this? Amazing.
This is real time.
This is basically real time. You can see the last update. So I thought, I could use this project and do something on my own. And besides, like weather, I like weather. Weather is awesome, like big storms and clear skies and snow. It's scary and beautiful at the same time. So hey, let's do a wind map. That sounds like a good project. So I started investigating what to use. Found D3, which we heard about earlier today. In fact, nice tutorial that describes how to use D3 to build a nice map. Nice tutorial. Long tutorial. Okay, so map, no problem. Where to get the data? Does the data even exist? How do you find the data? Well, I found U.S. National Weather Service has the GFS, which is a weather model, it's a simulation, runs on a supercomputer every 3 hours, and produces data that is free. Here's the FTP site. There, these are the files. You can just go down, download them immediately. They're in a weird format. very weird format, but you can download it. It's free. Okay, so construction. Where do we start? This was my first victory. The map of the world in the browser using D3. I thought, this is amazing. Okay, I can do this project. If I can show the map, I can do this project. The next step was to get it into a sphere. Also supported by D3. It's very nice. And then use the weather data to color the individual dots that represent the latitude, longitude grid of the weather data. So we color that in, and it starts to look good. And then between the data points, use bilinear interpolation to fill in the gaps, and you get a nice smooth sphere. However, that's just the colors. I wanted the moving animation. And that was hard. That was very hard. I tried many things to understand how to do this. And eventually figured it out. And I'll show you a demo right now. So this is the site. This is basically live data every 3 hours. Oops. And you can rotate the globe, zoom in, and you can see the weather system that just went through. There's a menu. Look at other types of data. So let's go to the jet stream. This is really high. The jet stream. Or we can see the jet stream over Antarctica. It's kind of neat. Or we can see the ocean waves. Again, that storm system creates a lot of waves. Or the ocean currents, like the Shiokuro. Kuroshio? Kuroshio, thank you! That's nice as well. And we can go forward and backwards in time, so we can see back in time how the current changes. We can also, because it's D3, this is built in, we can change the projection. Maybe something weird like this one. That's kind of fun. And also some, let me switch back here. This is PM25. Oh, hold on, there we go. PM25. Thank you, China. India is bad. But PM25 is not just pollution, it's also sand, dust, and salt from the ocean. That is also classified as PM25, so it's important to understand where the source of the pollution comes from. Anyway, so that's the site. So I just want to talk a little bit about how it's built. The globe is built out of 4 layers. There's a globe, it's SVG, and then a canvas, HTML5 canvas, where the animation happens. The colors are WebGL. I started out with canvas and then switched to WebGL for performance. And then finally another SVG layer to clean up some nice edges, to make it look nice. So let's talk about that animation. When you download the weather data, it shows you a vector field. It looks like this. And we want to draw particles on this field. So let's draw one small segment at a time. Draw the segment. Every frame, look at what the vector points you at and draw that direction. Draw that direction. Now let's fade the segments we've drawn previously. Let's fade that each frame and increase the speed and add more particles and add more particles and add more particles. And that's the effect. That's how you do it. Now I mentioned the distortion of the globe being a challenge. And it's a challenge because the weather data shows you the wind in north and east. But north on the display, north on the computer display, well, sometimes it's up, sometimes it's to the right, and sometimes it's down. So you have to figure that out. Same with east. So if you do that for every point, you find the distortion of how to transform the vector. And I'll show you how that works. Let's look at only east. Let's do the same thing. Let's draw a field, or draw a particle, one step at a time. Increase the speed. Right? That was the hard part of this project. Now I started out with Canvas for the colors, but switched to WebGL. And this is what the original implementation looked like. Whenever you would rotate the globe, the colors would disappear. Not great. Right? So let's write a fragment shader. Now a fragment shader is another name for creates a pixel color. It's a little program that runs on the GPU. And you write that program in GLSL. This is supported by all browsers. It's very simple. This is the simplest fragment shader. This is the return value. This pixel is RGB. That's it. Okay, so for the wind map, for every pixel, figure out what latitude and longitude that represents. Go look up the wind speed for that latitude and longitude, and then map it to a color. And it turns out this part here, mapping from XY to lat long, is the hard part. I use an orthographic projection. That's the just fancy name for globe-looking projection. And it has some formulas for calculating lat and long from X and Y. Well, we can write that in GLSL. We can write that in a fragment shader. And that's what this is. Great, it worked. Nice and fast. However, there was a bug. Some user emailed me this image. Who can see what's wrong? Do you see it? Everything is shifted down. Right? And it's weird because it shifted south. Not like down on the screen, but south. And the longitude looks okay. Everything lines up, right? And it's shifted down, but then like Italy looks okay and Africa looks okay, so it becomes accurate. This was really, really weird. So I started looking at this pixel, the fragment shader, wondering what it is. There's something wrong with this latitude value. So let's look. let's look at these terms. There's a problem with these terms. Well, the problem can't be here because longitude is okay, and it's longitude uses the same term. This is the same. This is the same. It's basically the same. All the terms are the same. So why is the latitude wrong? Well, latitude uses arcsine. This is a built-in function in the hardware of that user's machine, of the GPU. I thought that's really weird. Like, why would arcsine be wrong? So I created a little program, asked the user to run it. This is the output of arcsine on that user's computer using JavaScript, which runs on the CPU, and WebGL, which runs on the GPU. It does not line up. Arcsine is wrong. Okay, what do? Let's approximate arcsine. That's easy. Someone wrote that for us. There we go. That approximates arcsine using simple multiply and add. Okay, so let's add that. Make my own arcsine. It worked! So weird. The user's like, thank you so much, I can use your site now. I don't believe in global warming, and thank you so much. I'm like, oh. I can't believe I did all that work for someone who does not believe in global warming. So the lesson is, GPUs are designed for games, not computation. Unless it's an expensive GPU, right? Unless it has, because that user's arcsine, that hardware implementation had optimizations that were okay in a game world, but not when doing computation.
Was it only for the specific GPU?
He had like a 7-year-old GPU. However, I put in a little test to see how many users of the site have an incorrect arcsine. It's about 3%. 3% of visitors across, I don't know why, it's very weird, but I want to talk a little bit about the architecture of the site. It's all static. It all sits in Amazon S3 behind Cloudflare. Cloudflare is free CDN, free content delivery network. S3 is cheap. So running the site costs around $50 GoSan per month. And all the weather data is pulled from the National Weather Service with my own server, extracts it, JSON files, uploads the JSON files to S3. And that means, because S3 is scalable like crazy, and there's no servers to maintain, it's really great. All right, so this is scalable, but it was time to launch the site. Would anyone visit? So let's talk about reactions. So I launched the site on Twitter, on Facebook, with friends. And this is Google Analytics. Launched the site, 64 visits. Hey. And then it goes to nothing. And I thought, that's all of that work and nothing. And the next day, 30,000 visits. Or not next day, next week. The next week, it started going viral. So that was in 2013. This is 2013, 2017 total total traffic, 48 million users, 138 million sessions. These peaks represent typhoons, storms, heat waves. When nothing is going on the Earth, there's very little traffic, no traffic. But when there's something going on, people visit. And the most busy it was it was a typhoon, it was a hurricane hitting England. 2 million sessions in one day. Got some attention from NASA, Al Gore, Forbes, on Twitter. And it's been used on TV quite a bit. BBC, I forget which channel this is. This is a bit old, but I know that Hodo Station uses it sometimes. And this is US, the Weather Channel. Also used this artwork on some publications, some journals, Nature, Climate Change. Someone made a beer. Didn't tell me about that. I really wanted that beer. And then people made some very interesting artwork. This is a piece of fabric. This is a stitch artwork made by an artist in Canada. She made 20 of them and then did an art show, all based on that projection. So let's talk about lessons. Lessons about what I learned. First one, usability. No one knows where the menu is. I thought I was being clever. I thought I was being clean, nice design, but no one knows about the menu. Unless they've already played with it, and it's a bit, I have to fix that. Lesson 2. This visualization is very wrong is the wrong word. Misleading, incorrect. I'll show you why. So this is an animated snapshot in time. The clock is not moving. So what is this movement? That's not movement in time. That's movement of a vector field. If we take one particle and draw it out, what we get is a streamline. A streamline is a line in an instantaneous point in time. But that's not how the weather works. Vector fields change over time, like this storm is moving off to the right, and the clock is on. So let's do the same thing. Let's draw the same particle. Completely different track. This is closer to reality. But what you see on my wind map is the first one, streamlines. So people, it's misleading. It's not exactly correct, but people don't care. They kind of don't care about that detail. However, when we build data visualizations, we need to be honest. We need to be honest with our users and show them exactly, describe exactly what that visualization means. I've not found a good way to describe it to users, to visitors of the site. Since the site launched, there's been a lot of particle animations introduced. Weather Service, or CNN, Weather Channel, NHK came out with. I don't know if this is before My launch or after? Looks pretty similar. The other lesson, the data is free. The geographic data is free. The frameworks are free. All the bandwidth is free. All the help on Twitter that I got, all free. The weather data is free. Like, free stuff opens up huge possibilities for people like myself. Don't have a job, just want to build a project. This is billions of dollars. Billions. Rockets, satellites, supercomputers. I get to use it for free. We all get to use it for free. That's a huge lesson. The European Weather Service, Japanese Weather Service, Kishocho, not free. The data is not free. It's like 20万円 per month. 200万円 per month, something like that. I would love to use Japanese Weather Service data. I can't get it. Anyway, that is it for my project. Thank you very much.
ありがとうございます。Thank you very much. ご質問をいくつかいただいております。アースプロジェクトは一人で作りましたかというのと、アースプロジェクトはどのくらいの期間かかりましたか。I have a question. Did you make the Earth project by yourself?
Yes, by myself.
By yourself. And how long did the Earth project take?
I started in July, launched in December. 5ヶ月。
5ヶ月ぐらい。
5ヶ月。I made a prototype just about Tokyo. This is the prototype. But it's very, like, you can't do anything. And people saw this and they said, I live in Saitama. I live in Okinawa. How can I see the weather? So I made the globe. But 5 months. 5ヶ月かな。
And
when you have no job, it's easy to spend a lot of time.
So did you find fun areas to look at?
Oh yeah, there are many. This is so the wind around Antarctica, you don't realize it, but this ocean is, there's no land in the way. So the wind just goes and goes fast. It's called the roaring 40s. Very bad weather all the time. And it's because there's no wind, there's no land to slow the wind down. And, you know, what weather site lets you see Antarctica? Right? They always give you an exact window to watch. But this is a toy. You can explore and find things. This is also a new one, or an interesting one. Polar vortex. So this is stratosphere. 30 kilo, 100 kilo 上かな? So in the winter, it's our winter, right? North, yeah, we have a really strong vortex over the pole. In summer, this moves to the South Pole. So that's pretty cool too. Lots of interesting areas to explore.
あとは GPU についてもご質問いただいてます。
Binary format, which does differential encoding, kind of like PNG. It predicts, using 3 points, predicts a plane, find a delta, encode that. that gzip's really nice. So there's a lot of tricks. And all the whole architecture as well, like S3, Cloudflare, no server, it's all static. All the logic is in the browser. So I use visitor's CPU instead of my own. Lots of tricks. And one last thing, S3 is so cheap. I don't delete data. So every 3 hours until 2013 is available. 4 years of data so far. So you just keep.
はい、どうもありがとうございました。もう一度大きな拍手をお願いします。